Homework 9, compound interest, video 3, another compound interest example. Let's take a look at a real-world situation which may apply to you in the future or may have applied to your parents in the past. When your child is born, you invest $5,000 at 2.9% interest compounded daily. In 18 years, you withdraw your investment to pay for college for your child who was born 18 years ago. How much do you now have? How much money do you now have? This is an example of why you want to learn to invest, or at least get the idea behind investing. To buy something expensive in the future by saving for it now. Not that anybody is facing that crisis right now, mind you. Sarcasm noted. Well, this is a compound interest problem. How do you know? Easy. It says the word compounded. That's the clue that you're doing compound interest. So if we're going to use compound interest, we need to look at our compound interest formula and the pieces that we need to calculate it. One piece we need is the principal, which is how much we start with. That's just $5,000. Let me stop here for a second. Pause the video. See if you can finish the problem. Go ahead. Practice it now. Did you do it? If you paused, great. If you didn't, I don't know what else to tell you. All right, our principal is $5,000. Our interest rate is 2.9%, but we need to write that as a decimal, or rather a non-percent. So move the decimal 2 places to the left, get 0.029. If you wrote 0.29, you just changed it to 29% interest. If you can find an investment that pays 29% interest, let me know. I'll let in on it. Our time is 18 years. But our N is the number of times per year we get interest. So if something happens daily, how many times per year is that? Ignore leap years. The answer is 365. There are ways to make accommodations for leap years. One common way is to append 0.25 on there. That way every 4 years it picks up an extra day. But we're not going to be that nitpicky. Unless it says the banker's rule, you use 365 for the number of days in a year. All right, so now that we've got our values, let's substitute them into our formula. I meant to write the formula. I'll write it here. A is equal to P, open parentheses, 1 plus R over N, close parentheses, and then the exponent, N times T. So when we set it over here, we have 5,000, open parentheses, 1 plus, the interest rate is 0.029. We're going to divide that by 365. That's how many times a year we're getting interest. So we're taking this and cutting it up into 365 pieces. And then the exponent, the N, 365, times the number of years, which is 18. What this exponent represents is the number of times you're getting interest. I'm getting interest 365 times a year for 18 years. What this fraction represents is the interest rate each time you receive interest. So you can think of this as the daily interest rate. But I would not put this in a calculator, write down the answer to that. Put this in a calculator, write down its answer. You can do that, but the problem with it is every time you write down a decimal, especially here, you're going to be rounding it off. And when you round off in the middle of a problem, it creates a greater discrepancy by the end of the problem, sometimes so great that your homework would count it wrong because it's not close enough to the correct answer. You need to be able to put this into your calculator in one fell swoop. Just type what you see, and don't forget the parentheses. 5,000 times, open parentheses, 1 plus 0.029 divided by 365, close parentheses, press whatever your exponent button looks like, open parentheses, 365 times 18 close parentheses, and then equals to complete all the calculations. Or if it's a TI graphing calculator, you would press enter. Okay, 5,000 times, open parentheses, 1 plus 0.029 divided by 365, close parentheses, exponent, open parentheses, 365 times 18, close parentheses, equals. That's it? That's it? To the nearest cent, I got $8,426.80. Let me do that again. That seems kind of low. I can hear some of you screaming, that's what I got. Well, just because people get the same answer doesn't mean they're right. It just means they agree with each other. Agreeing doesn't always make something right, it just makes it popular. That's the same answer I got. Okay, so it's the correct answer. After 18 years, your $5,000 has blossomed into a not so impressive $8,426.80. And there are some colleges that you can go to for that much money. And there are some colleges that you can't. So it kind of raises a question. If $5,000 isn't enough, excuse me, if $8,426.80 isn't what you wanted after 18 years, what can you do to increase that amount? Well, there's a variety of things you can do. Invest more money. If this were $50,000, then this would be $84,000, and you would probably be okay. What else could you do to increase this amount at the end, besides raise the principal? Raise the interest. Find a bank that pays a higher interest rate. And I'm wondering, I'm just curious, what would happen if it were 3.5%, which doesn't look like a big jump from 2.9, but I'm going to recalculate it in just a second. We can increase the number of years. Maybe you want to invest before you start having kids and make this 20 or 25 years. And you could also increase the number of times you get interest. Recall the first example, when we did simple interest, that's like getting interest once. When we did quarterly, that's 4 times. And we ended up making more money. But as a general rule of thumb, if any of these values increase, so will your future value. But I'm just kind of curious, what would happen if we happen to find a 3.5% interest rate instead of 2.9? And it doesn't sound like it should make a huge difference. But let's see. I don't know if you tried to do it with 3.5%, but I did, and it more than doubled the money. Whoa, that's only 0.6%. But compound interest is very powerful. Just raising this ever so slightly, raised this to $17,814.57. So there's a moral to be learned there. Even though the difference in interest rates may be small, over time, that difference makes a huge difference. I'm not going to do it again, but I was just curious. Well, yeah, I am. I'm curious. What would happen if we found a 5% interest rate and locked that in? I just want to know how big our future value would be if this were 5%. 1 plus 0.05 divided by 365 plus parentheses. Exponent, parentheses, 365 times 18. I pressed something wrong, and why is this suddenly showing in scientific notation? Stop that. What did I do to make that happen? Where did that come from? This example is over, and I shouldn't be wasting time on this video trying to figure out how I accidentally put this calculator into scientific notation. But I can deal with it. But I do want to know what would happen if it were 5%, so we're going to do it again. What is going on here? Don't know how to get it out of scientific notation. Anyway, I'm going to pause the video. I'll figure it out at $5,000, excuse me, at 5%, and I'll just tell you at the beginning of the next video.